Hello, everyone. I'm excited to share a story about how artificial intelligence, something we usually associate with futuristic robots, actually helped me solve a very real, everyday problem. It all started with Youbike. After the government introduced a policy where the first 30 minutes are free, it became super popular. A lot more people started using it, especially students like me. But suddenly, it became really hard to find available bikes. Even worse, if you manage to rent one, you might arrive at your destination and find the station is full. So you can't return it. This happened to me more than once, and it was frustrating. Then I thought, could I do something about this using artificial intelligence? Could I predict which stations would be full or empty? That simple question led to an exciting project I want to share with you. So I came to ChatGPT with a clear goal. I want to monitor Youbike stations and record their data automatically. I want to track problems like no bikes or no empty slots. How do I build this? ChatGPT pointed me to something called the Youbike API. Now, if you're unfamiliar with the term API, it stands for Application Programming Interface. Imagine it like a digital waiter. You ask for information, and it brings you exactly what you need. It gives you things like how many bikes are available at each station, how many empty slots are left, and even the last update time. With ChatGPT's help, I wrote a Python script that accessed this data every few minutes and saved it into a CSV file. It worked, but not perfectly. The first challenge? File organization. I wanted each station to have its own file for easier tracking, but I had a hard time explaining that clearly. I'd type things like save by station name in folders, but ChatGPT didn't always get what I meant, so I did something simple that helped a lot. I took screenshots of my screen and shared them in the chat. I showed what my folder looked like, or where I wanted files to go, or what the broken output looked like. After seeing the screenshots, ChatGPT understood exactly what I meant and gave back the right fix. That back and forth process helped me improve the script step by step, handling errors, organizing by station, and saving logs automatically. Eventually, I had a system that could track any number of stations, log their status 24/7, and handle problems without crashing. Once logging worked, I wanted to take it further. Instead of just saving the raw numbers, I made the script track problem events. Specifically, when a station had no bikes and when it had no empty slots. For each of those situations, I recorded the start time and end time. That way, I could tell not just what happened, but how long the station stayed in that state. But now came the hardest part. How do I analyze time-based data? My first instinct was to average the times of events, but that led to problems. For example, say one no-bike event happened at 9 a.m. and another at 3 p.m. The average is 12 p.m., but that's meaningless. Nothing happened at noon, so I had to rethink time as a number. What if I convert time into a decimal scale between 0 and 1? For example, midnight becomes 0.00, noon becomes 0.50, and 6 p.m. becomes 0.75. By doing this, I could finally treat time like a number. Now I could analyze time like regular data. I also started grouping the events by 1-hour intervals to calculate the probability of a station being in trouble at each hour. That gave me a better view of when problems usually happened. I originally thought about making a 3D chart, one axis for time, one for station, and one for frequency. But ChatGPT suggested something much simpler and better: a heat map. A heat map uses color to show intensity. One axis is the station, the other is the time of day, and the color shows how often problems occurred. After building the heat map, I wanted to go even deeper. I didn't just want to know when problems happen. I wanted to know how long they usually last, and what's the worst case someone might face at each station. So, I wrote a program that analyzed all the logs for every station, calculating the longest wait time without bikes, the longest wait time with no empty slots, and the most common wait duration, or the mode. Using that, I generated PNG reports, one for each station, showing these patterns with KDE probability charts. KDE stands for kernel density estimation. It's basically a way to smooth out raw data and show where values are most concentrated. In my case, it helped me visualize how likely different wait times are, not just as a list of numbers, but as a smooth, easy-to-read curve. This gave me a clear picture of the highest risk periods and how serious the wait times could be. And the best part, the whole system runs automatically. Now, Let me quickly explain how to read these charts. At the top, you'll see two blue line graphs. These show the wait time distribution for two situations. No bikes available on the left, no empty slots to return your bike on the right. The colored lines show the shortest, longest, and most common wait times at that station. Below the line graphs, you'll see two heat maps. The heat maps show when problems usually happen, broken down by day of the week and time of day. The darker the color, the higher the chance of running into a problem during that hour. With this view, you can quickly spot which hours and which days are most risky at each station. Now, I'm showcasing the results of some of the most important stations on campus. Stations near lecture halls, dormitories, and MRT exits. Let's take a look. This is just the beginning. Right now, this system helps me understand bike availability, but there's so much more I hope to do. First, I want to move this project online so I don't have to keep my laptop running all day just to collect data. Second, I plan to add machine learning to predict bike shortages at new stations, even before they open. And third, I want to explore weather data to see how things like rain or temperature affect bike usage. Imagine a system that not only tells you where bikes are now, but also predicts future shortages or warns you before you even leave your house. That's the future I'm working toward. Finally, I want to thank you for watching this video, and I hope this inspires you to look around, find a small problem that bothers you, and start exploring how you can solve it. With curiosity, persistence, and the help of AI, anything is possible. Thank you for watching. Have a good one.